So we've seen the reading functionalities now. So we didn't really mention in the previous videos the arbitrary writing functionalities of the nanophraser, which can also be used sometimes. So let's see them very quickly. So similarly to the reading arbitrary, we can select an area which we want to write, a rectangle, a square, and we can finally decide its dimensions, pixel size. Let's say we want to use TSPL. We use a pixel size of 20 by 20. For the laser, we can use a pixel size of 100 by 100, and also select the power. So in this case, you also see the number of pixels that we have on X and Y, the time, which is quite short. And it's quite straightforward. We can already see for these fields, it will take very little time with the laser. We write this rectangle 17.4 by 6.48 in 10 seconds. And similarly, we can also do the same with the TSPL. So we put our pattern in here. And maybe we change our, you see we have 6 fields because we have very large pixel size, 100, which is very uncommon for TSPL. It's a pixel size that's common for laser. A very large pixel size leads to a very short, sorry, not very short, very large patterning speed. So we have a very large scan region, which leads to having a scan region that's larger than the piezo scanner extension. So we have to split in multiple fields. So we can just decrease the pixel size to a more reasonable value. If in case we want to keep this 100 nanometers pixel size for writing, we can also change the pixel time, because if we increase the pixel time, we will decrease the patterning speed. Therefore, we will also decrease the extension of the scan region, which we mentioned earlier. It's dependent on the acceleration that we need for reaching a certain speed of patterning. So if I put here 100, so we increase the pixel time by 4 times, the scan region area will also be decreased. So you'll see now it's only, let's try to refresh. So now it's only 1 field, which makes quite a lot of sense. But let's try to keep values of pixels a little more standard for TSPL. So yeah, rather than 50, let's put 30, for example. And let's go back to normal pixel times. So instead of putting 100, you can put back to 20. We can now again select some patterning parameters. We can use Kalman with initial writing force of 3.5. Let's put a forward height of a bit higher. And we can put a depth at 35 nanometers. So we can also control the depth of our square. Now we press play. And of course, now we need the feedback to work a little bit, because we are setting manual patterning writing forces for the initial lines. So we will also see our Kalman feedback working while patterning. Actually, now I'm writing on the pre-existing field, which is not a good idea. So sorry, let's stop this patterning and let's move our geometry somewhere else. Not the smartest move from my side. So let's place it here in a clean area. And let's start it again. You can also check from here the quality of our tip. So we've been using our tip for quite some time, and also checking the history can help sometimes to have an idea of what's happening to our tip, if there are some contaminations or some chipping events. In this case, it seems like the adhesion length is slightly increasing, so probably we're ruining our tip a little bit, but still seems like the quality is quite good. And you can see that our pattern is decent, except some few imperfection in some lines. Maybe we can and we see that the feedback is oscillating a little bit. So the best thing that I would recommend maybe is to either use a constant force or use a force that was giving us a good depth. Like here we see that we're patterning well for this line at around minus 2.4. We can see which force we are using. Which is around 3.75. So we could run this again with this 3.75. And we hope to get a better result. So this is a very brief introduction to patterning arbitrary areas with either the laser or the TSPL. Sometimes it can be useful either to check some patterning or capability of both the laser of the TSPL, or maybe if we want to do some small fixes with arbitrary regions, it's something that you can easily do. So we can stop the video now, and we will see more advanced features in the next videos.